Hello, hello. Good morning, everybody. Um, I had to run some errands today, so I'm sorry I had to miss your class today, but I'm joining you via video, right? So if you haven't already, pull this guy out, lesson 4 homework practice. I was contemplating collecting this, and today I might. I'm still thinking about it, so kind of depends. But here's the deal. You have goals for this semester, and I'm so excited for you because you guys graduated from baby, like sweet little adorable baby algebra, up to this 2-step equations, and you are solving them and you're showing your work, and I'm so proud. Like, I'm phenomenally proud. Your quizzes were amazing. I can't wait to see what you're going to do on your quiz at the end of this week. So today what we need to do is think with the end in mind. So your goal for this chapter to mid-chapter, to end the chapter strong, you have goals, you have action plans. One thing that many of you said you want to be better at was getting your homework done, but not just that, but checking your homework once it is done. So this is one of those opportunities where I'm not there with you right now, so you're going to have to really dig in, listen, be paying attention, looking at your paper while you're looking at mine, making sure your work matches, and if you don't understand anything, that you're getting it down, because we're going to practice more today. We're on to more 2-step problems that are a little bit more advanced. So, and you're going to be awesome at them, but let's start here. Let's look, remember, we have to solve each equation, which is showing all of your work in order with lines and things, if that works for you, and then checking your solution as well, fully checking, okay? You don't want to make the same mistakes that Elisa did yesterday on that example I showed of Ben and Elisa. So here we go. Let's take a look at number 2, because it's got one of those fraction ones. I figured you'd like to see me work this puppy out. So my suggestion is go ahead and make a nice line down the equals so that whatever you're doing to the left, you're also going to be doing to the right. And we're going to get rid of what first? What do we call that little guy that does not have a variable? It's the constant. We need to get rid of this constant so that then we can handle our y here. So in order to get rid of a positive 5, we're going to subtract 5. Whatever I do to my left, I have to do to my right as well, okay? So now that stuff's out of there. I have -9 and -5. That's same signs, add and keep. So it's going to be -14 equals, I'm just going to take this 2/7 y and recopy it down here, because I'm not done with it yet. This is my second part of the step, okay? So now I have 2/7 y, easy for me to say, equals -14. And in order to get rid of this 2/7 y, what do I need to do? Well, yeah, I'm dividing by 2/7, but you remember what dividing is. Dividing is just multiplying by the reciprocal. So let's multiply each side by the reciprocal of 2/7, which is 7/2. Now, that's much easier to say, 7/2. Now, 7/2, of course, we just cancel this out. It leaves us with y. Y equals, well, I'm going to do some work here. I'm going to do some cross canceling. I can fit 1 2 in here, and I can fit -7 2's right there. So if I have -7 times 7, I'm going to end up with -49. Please excuse my little baby sign right there. Now let's check that, okay? Because if I plug -49 back into my equation, I should have equal things on each side. So -49 times 2/7 plus 5 equals -9. All right, so let's go ahead and multiply this out. I'll go ahead and cross cancel here. This is going to be -7, and this is going to be 1. So 2 times -7 is -14 over 1, which is just -14, plus 5 equals -9. Don't you dare stop there. Finish it up. So negative and a positive, different signs subtract. Keep the sign of the bigger number. So I'm going to have a -9 equals -9. Boom, you did it. All right, let's go just right down below that. Let's look at 5k -7 -7, because some of you got a little thrown on this one. Get rid of the constant. +7 +7. Boom. Okay, so now I've got 5k. Let's just rewrite it down here. Equals, what's -7 plus 7? Nothing. If I have 7 cookies and then you take them away, I have 0 cookies and a sad face. No cookies. So now I still need to get rid of that 5 by the k. The opposite of multiplication is division. So if I divide both sides by k, boom, I've got 1k. K equals 0 divided by 5. If I have no cookies and I put those no cookies into 5 groups, each group will have no cookies. So K is 0. All right, so let's check that out. If my value for K is 0, I'm going to plug it back here for my check. So 5K minus 7 equals negative 7. 5 times 0 minus 7 equals negative 7. Well, 5 times 0 is 0. And what do you know? Negative 7 absolutely equals negative 7. That's a lot of 7s over there, isn't it? I mean, you really could see from right there that those were equal. Okay, friends. Let's look at this one. Put a line down the side here, getting rid of my constant. Now, it's okay if the constant's on the outside. That's why I chose to show you this one. Because sometimes people freak out when they see the 19 over here and they're used to seeing, you know, the constant in here. But guess what? You treat it exactly the same. So if this is a positive 19 and I need to get rid of it, I'm going to minus 19 on both sides of my equal sign. Yeah, this is really far over here. So be careful that you're subtracting it from both sides indeed. Okay, so I have 19 and 19. Excuse me. I'm left with 13x. I can just pull that straight down, equals 32 minus 19 happens to be 13. Now I've got to get rid of my 13, so I divide by positive 13 on both sides. That leaves me with x equals 1, okay? And if I'm going to check it, I don't have a lot of room over here, so forgive me if I come up top over here. I mean, if you fit in the margin, it's totally fine. I mean, it's fine. So I've got 19 plus 13x. And that equals 32. So I have to plug this in over here. 19 plus 13 times 1 equals 32. So it's 19 plus 13 equals 32. And 32 really does equal 32. So we're good to go. All right. I think that's okay for everything up top. Let's look down here at number 13. So number 13 is a nice word problem for you, and it's mad confusing. There's lots and lots of information, isn't there? Yeah, and so we need to really, my suggestion, don't be overwhelmed by all the words. Let's break it down step by step. That's not going to help if you can't see anything, is it? Let's break it down step by step and take a look at what this is saying. Okay, so it gives us some information. It says kittens weigh about 100 grams when they're born, and then they gain some grams every day. That's just info. That's just telling us kind of how kittens roll, okay? Kittens are about 100 grams, and then they gain a lot of grams each day. So if a kitten weighs 100 grams, so that's what it starts as, right? At birth. And, what does and sound like? Sounds like plus to me. Gained also kind of justifies that this is a plus. 8 grams per day. How many days will it take the kitten to do something? So 8 grams per day, that is 8 times D every single day. So we're multiplying, we're adding 8 every day. And we don't know what days are because it says how many days. So it looks like something's going to be 8D. And then how many days will the kitten triple its weight? How much did it weigh in the beginning? Well, it weighed 100. So triple its weight is 3 times 100, which is 300. So we've got a couple of things. We've got 100 grams. So let's write that down. 100. And they're gaining 8 times D. And that's going to equal 300. So in order to solve that, we need to get rid of this constant over here, minus 100 on both sides. And we've got 8D equals 200. And then we're going to divide by 8. And I'm going to come over to the side and say, well, 200 divided by 8 is 25. 25 what? Grams. No, not grams. 25 days. That's how many days it will take before that kitten is going to be 300 grams. Now it's going to triple its weight in a little under a month. So that's pretty cool. Don't worry about number 14. This is really the one I wanted you to get. All right. Now, let me back out of this just a little bit. Do I want to gather this from you? Let's see. Did you do your best to look over this while I was going over it with you? Keeping it in mind and your goals, checking to make sure that you got everything. Were you doing that? Okay, then you hold on to it. We're good. Go ahead and turn to page 482. We're looking at 482. It says this at the top. Solve two-step equations. Page 482. I'll give you a second to get there. All this lesson is called Morse two-step equations. So we're just doing different types. So if you thought it was pretty fun doing those first ones, wait till you see these ones. I'm just looking to see if we got time here. Nah. All right. All right. So on page 482, we start looking at some different kind of examples. And I want you to look at solving these algebraically. So take a look at this one up here. We've got an equation, 3 times the quantity x plus 5. Now, when we did 3 times the quantity x plus 5, what property did we use to solve that? Shout it out. We distributed it, right? We did 3 times x and then 3 times 5. Well, guess what? You don't have to do that. I'm going to save you some steps because 3 times x plus 5 really is just 3 times some quantity, right? Can I get rid of that 3 by dividing both sides? Since I've got 45 over here and there's no x's or anything, yeah, let's do it. Let's go ahead and divide both sides by 3. That way we can get rid of that 3. And then what do we have on our own? X plus 5. And x plus 5 equals 45 divided by 3, which is 15. So see how we've got our steps one by one? Now we've got this problem. It's our new equation. And then we're just going to get the constant away. So we're going to minus 5 on both sides. And I'm left with x equals 10. All right? Of course, you know me. These examples are great. But I know you guys, you're not actually writing for these examples. Let me show you one more. We'll do one together in the margin after this, okay? So I've got 5 times n minus 2 equals negative 30. Let's get rid of that 5. It's being multiplied, right? So to get rid of it, naturally, we would divide. So divide by 5, boom, get rid of 5. 5 divided by 5 is 1, so we're just left with n minus 2. Negative 30 divided by 5. Well, positive divided by a negative is still negative. So that's going to be negative 6 equals n minus 2. Get rid of that 2 by adding on both sides. Boom, we're left with n equals negative 4. And then, of course, we're going to do a check. It says check the solution. It doesn't show you the check. But when we do our example up here, we are a check-in. All right. Sorry for the sniffles. All right. Please write this one up in your margin. It is 12 times the quantity, x minus 20. Oh, for the love. Equals negative 48. And we're back. Take just another 3 seconds to write that down. 12 times the quantity, x minus 20 equals negative 48. Okay, let's get rid of the 12. Let's get rid of it. See, in the past, we were getting rid of the constant, weren't we? Why can't we do it now? Well, because we've got parentheses. And yeah, PEMDAS says to do the parentheses first, but did you realize we're actually kind of doing the opposite of what PEMDAS says in order to solve? We're stripping it away step by step. So we get down to this x right here, okay? So let's get rid of the 12 from both sides. We're going to divide, and you know the sign for division is a line, so divide by 12 on both sides. So these 12s are going to cross out, and I'm left with the quantity x minus 20. You can remove the parentheses now because we're not multiplying anything by it, so we don't have to do anything else there. And then negative 48 divided by 12, a negative divided by a positive is going to be a negative. And 48 divided by 12, oh, you know what? In my example, I subtracted it. Oh, that's hilarious. Okay, so 48 divided by 12 equals 4, negative 4. All right, and then if I am trying to get rid of this negative 20, I'm going to add 20, right? Get rid of this 20, and I'm left with x. Let me write this in a different color because I'm getting over that red a little bit. And what is 20 and negative 4 when we combine those? Well, different signs subtract if we're looking at our rules, and we're left with positive 16. All right, so our answer is positive 16. So let's check this. If I have 12 times the quantity, x minus 20 equals negative 48. I'm just writing out the whole thing because sometimes I get goofy. And now I'm going to replace it, okay? So 12 times the quantity, I have 16 minus 20 equals negative 48. So let's do parentheses. PEMDAS says parentheses first, 12 equals 16 minus 20, that's negative 4, equals negative 48. And what is negative 4 times 12? Well, that is negative 48. And we're good. Boom. Okay, here's what I want you to do now. I want you to do one or two that are like this, and I'm going to give you a little bit of room. So down here, I want you to do A, and I want you to do C. So spread out and take your room a little bit. I'm going to do them as well on the side. So I'm going to give you lots of time, so you don't need to pause the video or anything like that. Mrs. Ford, we are good to go. So step by step, start with dividing by what we're multiplying the quantities by. And everything inside me wants to distribute that out. Don't you? Don't do it, Mrs. Blake. Get rid of it. Don't distribute it. Take about 30 more seconds and get as far as you can. Okay, let's look at A, okay? A! What am I going to divide by on each side? Get rid of that 2. 2! So I can get rid of this. 2 divided by 2 is 1, and I'm left with x plus 4 equals, what's 20 divided by 2? It's 10. Now I can get rid of this constant. How do I get rid of a positive 4? I subtract it, minus 4, right below on both sides. And then I'm left with x equals 10 minus 4, which is 6, or 10 and negative 4, however you want to look at it. That's going to be 6. Okay, so let's do my check. The check, I'm going to take that exact expression up here, 2 times x plus 4 equals 20, and now I'm going to replace x with 6, because that's what I've decided x is, right? So 6 plus 4 equals 20. PEMDAS tells me I have to do what's in that parentheses first, so I'm going to keep my 2, and what is 6 plus 4? 10 equals 20. What is 2 times 10? 20 equals 20, and we checked. Brilliant. All right, let's bring it over to the negative over here, negative 7. Now, what am I going to divide each side to get rid of that negative 7? Not just 7, negative 7. If I just divide by 7, I've got a negative divided by a positive, and that's going to be negative, and that's going to leave me negative 6 times plus d. Quantity 6 plus d. That's even more hairy than on anything else we've seen. So we're going to divide by negative 7, because a negative divided by negative is a positive 1. So that's going to leave us with 6 plus d equals, and 49 divided by negative 7 is a negative 7, right? 49 divided by 7 is 7. A positive divided by a negative is a negative. Now, hopefully you got your signs all right, because that was the hardest part of this one. That's why I wanted you to try it. Now I can get rid of, I think this is supposed to be a D, not a 9. I was like, where's my variable? There it is. So sorry. So because my variable's right here and my constant is out here, I need to subtract my constant. So let's subtract 6, because that's a positive 6 from both sides. And I get D equals 7, 8, 9, 10, 11, 12, 13. These are both negative. Same signs, add and keep, different signs, subtract. I won't sing to you. I know you love it too much. All right. So that's my answer to that one. It's a negative 13. Okay. That sign is important because when we put this back in our check, let's do negative 7. Okay. Here's our check up here in the corner a little bit. Get a little bit closer. All right. Negative 7, 6 plus negative 13 equals 49. That's a little crazy in there, but if you think about it, it's negative 7, and then it's different signs subtract. So 6 minus 13, ouch, sorry, I'm itchy, is negative 7 equals 49. Different signs subtract, keep the sign of that bigger number. And then negative times a negative is a positive. 7 times 7 is 49, so it's an easier check than you think. 49 is 49. Awesome. Next page, please. Okay, of course, we're going to make this a little bit more complicated, but it's nothing you can't handle. In this example, we've got those dreaded rational numbers. We've got those fractions. So if we're looking at this and we're trying to get rid of 2/3, we're going to do just like we do on every other problem where we have that. We're going to multiply by the reciprocal, right? And you know me, I like to have these parentheses over here, and I know it's funky that it's right there. I usually put it on the outside, but that's okay. So this is going to cross out and leave me with n plus 6 equals, and they're showing you their little cross canceling to get n plus 6 equals 15. And then we just take away the 6 and we're left with n equals 9. And of course, we're going to check it. No biggie. No biggie. And this example down here, I don't even really need to show it to you because it's just got decimals. So we're just going to divide by 0.2. We're going to use a calculator or do long division to divide by 0.2, as long as we're paying attention to the sign. All right. So in your margin, please write the following problem. 5/9 times the quantity, 8 plus C equals negative 20. 5/9 times the quantity. Oh, I love that pencils are moving, moving, moving. 8 plus C equals negative 20. This has got negatives and fractions. Boom. We're going to rock this out. Okay. How do I get rid of this 5/9? Well, since we're multiplying, I'm going to divide by 5/9, right? But that's crazy because if you divide fractions, it gets funky. But we're going to keep change flip. So that's why we multiply by the reciprocal, 9/5. Both sides. Okay, we're going to cancel these out and we're going to be left with 8 plus C. Over here, remember, you could do like I do. I usually add a little 1 underneath my integer because I want to think of it as a fraction when I'm multiplying times a fraction, because then I can think of numerators and denominators. So I'm going to cross cancel. I want to get rid of this 5, 1 5, and how many 5s are a negative 20? Negative 4 5s. Now I have a negative 4 times 9. That is negative 36. Okay, so here's what I'm working with right here. I'm going to get rid of this 8. This is a positive 8, so let's subtract 8 from both sides. Don't forget your integer rules. I told you they were not going anywhere, friends. 36 and 8, we're actually adding those together because it's like a pile of negatives and we're just adding more negatives into the pile. Okay, so negative 36, same signs, add and keep the sign. So it's going to be negative 44. So there's my answer. Now, the trick is plugging that back into this one. 5/9, copy this down with me. Let's replace 5/9 times 8 plus negative 44 equals negative 20. Now, we're doing parentheses first, so let's keep our 5/9. And then, what is 8 plus negative 44? Well, it's different signs subtract is what you're actually doing. So if we're subtracting and keep the sign of the bigger number, 44 definitely has the largest absolute value. So keep the sign of the bigger number. 44 minus 8, you can plug it in your calculator. That's just fine. Negative 36, and that equals negative 20. Okay? Now, I'm gonna put a little 1 under there because I wanted to do some cross canceling. 1 9 fits into 9, and then negative 4 9s go into negative 36. So 5 times negative 4 is negative 20 equals negative 20. Boom. All right, friends, I would like you to do D and F. Actually, let's just do D. Just do D. I'll give you some time. To get rid of that negative, 1/4, we're going to multiply by the reciprocal. Whew, that was a doozy. I just finished. I made a mistake. I had to catch my mistake and go back. So, oh, those signs. Okay, so we are going to multiply each side times 4 over 1, 4 over 1, right? Okay, let's cancel out these. I'm left with D minus 3 equals negative 60, because 15 times 4 is 60, and a negative times positive is negative. Now, be very careful. This is negative 60 and negative 3 over here. So we're going to add 3 and add 3. When we are taking negative 60 and we're adding 3, we're actually subtracting and keeping the sign of the bigger number. So D equals negative 57. I actually added 60 to 3 the first time through. When I did my check, I was like, what is happening? It's because I didn't follow my rules. Let's do our check. 1/4 negative 57 minus 3 equals negative 15. 1/4, well, negative 57 minus 3 is the same as change. So it's like adding 57 and negative 3, which is negative 60, equals negative 15. 60 divided by 4, negative 60 divided by 4 is negative 15, and negative 15 equals negative 15. That was kind of a tough one with all those signs. Be super careful. The last thing I'm going to show you is on page 484. And that's because these are kind of tough to write, to take word problems and write it in a, always tough to write word problems as equations, excuse me. So let's think about this. Jamal and 2 cousins, how many people is that? 3 people. They received the same amount of money. Let's call the money M to go to a movie. Each boy spent 15 bucks. Afterwards, they have $30 left altogether. So they have some money and they subtracted $15 and they still have some money left over. So M minus 15 is really how much they spent. And how many of them were there? 3. So we've got 3 times the quantity. M minus 15 equals 30. That's how much money they have left. So if we took their money, took away the $15, whatever they had left, times the 3 of them, that's going to equal $30 total. Crazy, I know. And then we're going to divide by 3 on both sides, subtract by 15, and then we're going to get $25 for each of them. Okay, that's a little funky. So take a look at 5 down here, and I'm going to walk you through another one. Mr. Singh had 3 sheets of stickers. Got 3 of something, right? So it's probably going to be 3 times some kind of quantity. Let's look. He gave 20 stickers from each sheet to his students. And at the end, he has 12 stickers left. So my equals is going to be 12, right? At the end, it's going to be 12. That's how much he's got left. So he gave 20 stickers from each sticker sheet. How many stickers is on the sheet? We don't know. Let's call it S. But we do know he gave away 20. What does give away sound like? It sounds like minus. So we've got however many stickers are on that sheet minus the 20 he gave away. And he did that 3 times because he's got 3 sets of stickers. So 3 times S minus 20 equals 12. And you guys can go ahead and solve that. Divide by 3. S minus 20 equals 4. Plus 20 plus 20. Stickers. There were 24 stickers on each one. And I never skip the check, but in lieu of time, I'm going to skip the check that time and hope that we were correct. Okay, what I'm going to do, I'm going to have Mrs. Ford do, is she's going to pass out to you your assignment for today. It's a lesson 5 homework practice, and it's just like the one I gave you yesterday. So it's lesson 5 homework practice with more 2-step equations. So please solve, and then please check your answer as well, okay? Let me look through these really quickly and just make sure there's nothing I want you to skip. Nope, it looks good. I actually adjusted it a little bit. So lesson 5 homework, go ahead and get busy, and I will see you tomorrow. I'll bring this in completed tomorrow. Tomorrow, we are going to, while she's passing this out to you, we are going to go over some of this, answer any questions that you have. I'm going to give you a skill check review for skill check 6.2, because this is all skill check 6.2 is just more multi-step, 2-step equations, okay? I'm going to give you a review probably for homework, and we're going to play a little bit of a game that helps us to practice some of these so that you're ready for the skill check. And then our skill check is going to be on Friday, okay? You're going to be amazing. Amazing. Have a great one. See you later today, probably.